All right, this is Mr. Weideman, Lafayette High School, Functions in Trigonometry, help on DeltaMath, graphing trigonometric functions. This is probably the most challenging one of the take-home quiz set. And the one here, this is just going to involve some work. We know that this is a cosine function, and we need to start with our parent function. Right, this is a t-table that we have down stone cold for the cosine function, and then we're going to apply our translations A, B, and C to it. All right, and by this time, we need to know how to recognize what A, B, and C is and how to apply each one of those translations. I am going to make a little learning point here. This function, is actually written like this. It's 5/4 x minus 5, which is very, very different than including that 5 in parentheses. Right? If I include that 5 in the parentheses that I've shown here, that becomes then a horizontal shift. The 5 right here, this is a vertical shift. All right, so they did not include these little brackets. They're not necessary. They're implied. So that's one thing that we have to recognize. And you'll also notice on this particular assignment, we don't have any horizontal shifts. They're all vertical shifts. Okay, so we know what A, B, and C is. Actually, we don't call that C. We call that, in our class, we call that D. That is a vertical shift. Okay, correction. All right, let's move on then. So what do we do with the 2? We multiply it to the y's. What do we do with the 5/4? We divide it into the x. What do we do with the negative 5? We subtract it after we've multiplied the y's by 2. All right, so let's set up our t-table. X divided by 5/4 is the same thing as multiplying by the reciprocal. We can set up this little translation function, multiply our y's by 2 and subtract the 5, and we'll still do everything in order and not mess anything up. So everything in our t-table is going to be multiplied by 4/5, which is the same thing as dividing by 5/4. And so we're just going to do a little bit of arithmetic on the x part of the t-table, do a little bit of arithmetic on the y part of the t-table, and then we're going to have a function that we're ready to graph. Before I do that, when we get this function, and what makes this assignment difficult, is you set up your own scale. And when we set up our own scale, they give you 2 little boxes. One sets your x-axis, and the other box sets your y-axis. Now here, what I do is I usually put in 1 pi, and then I drag and drop it wherever I want it. So in here I put in 1 pi, and I dragged and dropped it onto the x-axis. But look where I put it. Exactly 1, 2, 3, 4, 5 increments away from 0. Why did I do that? I did that because I look at my denominator here. If I set it at 5, then that means that each of these little tick marks is 1/5, 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, which is as big as my x-axis go. It goes over to 8/5 pi. All right, so that works, I would say, about 90% of the time. You may have a least common multiple that just pick a least common multiple that is an even number and drag and drop your 1x onto that number. And I would say about 90% of the time on this assignment, you're going to be good to go. Yeah. So the y-axis, I would say about 90% of the time you're going to be good to go. Just putting 1 unless you have a really big stretch and a really big translation. Okay, so For this one here, it's perfectly fine and to use 1, and that's going to scale that y-axis in increments of 1, just like we have here. Now I'm just going to show you something that's going to make this easier to plot. You don't have to do it, but you'll notice here I kind of put in this dotted line right here. That is my vertical shift, which means that's going to make my neutral axis move down to 5. Now when I plot the points, I mean, I'm going to be able to see this. And look at the -3. That is an amplitude of 2 up. Look at the -7. That's an amplitude of 2 down. So doing that, it just kind of orients me on my graph. It kind of lets me know that I'm doing things right. You don't have to have it. If I just plot these points, all right, I'm going to get this little function right here, and then it asks if you want to submit it. And one thing to notice, these are all periodic functions. So everything you see should fit a pattern, especially the x's. 2 pi, 4 pi, 6 pi, 8 pi. That's a pattern. 2, 4, 6, 8. Denominator 5. Look at these guys. They're a pattern. They start at 3, go down, and then come back up. All right, which is what a cosine function does. It makes that dip. So that's a little hint as to whether you're doing things right or not. All right then, like I said, this is the tricky part, setting that x scale. You get to set it wherever you want. All right, so I usually, like I say, I take 1 pi and I set it at some sort of least common multiple of my denominators. And I hope that works for you.